Hi, good day. Welcome back to our class in Biochemistry Laboratory. Today, I will be demonstrating to you the activity number 4, which is on carbohydrates. Now, by carbohydrates, it means that this is a biomolecule that is composed of carbon, hydrogen, and oxygen, wherein the proportion of the hydrogen and the oxygen is similar to that of water, which is H2O. That's why the general formula for carbohydrate is CnH2O. For the first part of this activity, we're going to test the solubility of the carbohydrates. So we will use the following: the arabinose, the fructose, the glucose, sucrose, and starch. And we will add this with water. So to the first test tube, we are going to add here the arabinose. So this is the arabinose. Let's just use 2 pinches of the arabinose. Arabinose. That's arabinose. Next, we have the fructose. This is the fructose. Then this is the glucose. Then we need the sucrose. Here is the sucrose. This is actually the table sugar. And the last one is the starch. So to each of these test tubes, we are going to add 2 ml of water. To the arabinose, we're going to add 2 ml of water. To the fructose, we're going to add 2 ml of water. To the glucose, we're going to add 2 ml of water. Then to the sucrose or the table sugar, we're going to add 2 ml of water. And to the starch, 2 ml of water. And because we're going to prove its solubility, we're going to shake each of these mixtures. So look at the arabinose. This is the arabinose after it has been shaken with water. Then the second test tube containing the fructose, which we added with water. Let's shake it, whether it's soluble in water. So this is fructose shaken with water. This is the glucose added with water, and let's shake it to test its solubility. Then this is the table sugar or the sucrose added with water. Then let's shake it whether it's soluble in water. And the last one is the starch added with water. And let's try to shake it whether it's soluble or not in water. Observe what happens. So, to these 5 test tubes, wherein this test tube contains the starch, the sucrose, the glucose, the fructose, and the arabinose. I want you to observe whether these carbohydrates are soluble in water. Remember, the arabinose, the fructose, and the glucose are monosaccharides. The sucrose is a disaccharide, while the starch is a polysaccharide. So what can you say about the solubility of these groups of carbohydrates? For the next part of the activity, we're going to have the reactions of the carbohydrates. For the first reaction, we're going to demonstrate the Moly test. So, we're going to use here the glucose, the sucrose, and the starch. For this specific type of reaction to be done with the carbohydrate, we're going to use here the glucose, the sucrose, and the starch. Glucose. We will just use about 2 ml. So that is glucose. Then we will use the second carbohydrate, which is sucrose. And for the third test tube, we're going to use the starch solution. And to the first test tube, we are going to place this only with 2 ml of water. This will serve as our control. To each of these 4 test tubes, we are going to add 2 drops of the alpha naphthol. So this is the freshly prepared alpha naphthol. Then we're going to shake this mixture of the carbohydrates and the alpha naphthol. And to these 4 test tubes, we're going to run down slowly the sulfuric acid, a concentrated sulfuric acid. This is the concentrated sulfuric acid. So we will observe it later. This is the mixture of the glucose and the alpha naphthol, and we will add it with the sulfuric acid. This is the mixture of the sucrose, alpha naphthol, then added with the sulfuric acid. And this is the mixture of the alpha naphthol and the starch, and we will add this with the sulfuric acid. And we will observe this later. I want you to observe the formation of the violet ring somewhere in the interface between the alpha naphthol and the carbohydrate. The second reaction that we're going to exhibit with the carbohydrate is the Saliva test. So this is the Saliva reagent. We're going to use 5 ml of this, and we will react this with the carbohydrates. So we're going to put 5 ml with this. Then to each of these 4 test tubes, we're going to add for the first test tube, the water. Then to the second test tube, we add here the glucose. To the third test tube, we will add the fructose. And to the fourth test tube, we're going to add the arabinose. And we will place this into the water bath. Then with these 4 test tubes containing the Saliva reagent and the carbohydrates, particularly the glucose, the fructose, and the arabinose, we're going to place this into the boiling water at the same time. Arabinose, fructose, glucose, and the water. And let's observe it for 5 minutes. What happens to the color of the carbohydrates? Take note of the color of fructose as compared to glucose and arabinose, as well as to the water. This is the arabinose. This is the fructose. This is the glucose. And this is the water, which serves as the control. So that was the result of the reaction of the carbohydrates with the Saliva Enops test. Then the next test that we're going to demonstrate is that of the Tollens fluoroglycinol test, or the Tollens fluoroglycine test. We will use the same carbohydrates as in the test for the Saliva Enops. So we will use again 4 test tubes. And to these 4 test tubes, we're going to fill them with 5 ml of the fluoroglycine reagent. So this is the fluoroglycine HCl reagent. We will use 5 ml of this. Then, to the first test tube, we're going to add it with 2 ml of water. To the second test tube, we're going to add this with 2 ml of glucose. To the third test tube, we're going to add this with 2 ml of fructose. And to the fourth test tube, we're going to add it with 2 ml of arabinose. And we are going to immerse this 4 test tubes into the boiling water at the same time. Remember, this is the arabinose. This is the fructose, second one. This is the glucose. And the fourth one is the water, which serves as the control. And we're going to heat that for 15 minutes, but we're going to take note of its color after the first 2 minutes of heating it in the boiling water. 2 minutes had passed, so we're going to take note what had happened to our heated or boiled mixture of the carbohydrates reacted with the fluoroglycine. So this is the carbohydrate arabinose added with the fluoroglycine reagent. This is that of the fructose plus the fluoroglycine HCl reagent. Then this is the glucose added with the fluoroglycine HCl reagent. This is the water added with the fluoroglycine HCl reagent. Then let's observe it for the next 15 minutes. What will happen to the color of these carbohydrates when reacted with the fluoroglycine HCl reagent and being heated. So let's take a look again of the carbohydrates after 15 minutes. This time, compare the change in color between arabinose and the glucose. The next reaction that we're going to perform here with the carbohydrates is the Fannings test. We're going to use 4 different kinds of carbohydrates. So we will be prepared. Okay. So we will be preparing 5 test tubes, 1 for the water, 2 for the glucose, 3 for the fructose, 4 for the sucrose, and 5 for the starch solution. So we will put 1 ml of each of these test tubes with the carbohydrates. To the first test tube, we will put water as our control. To the second test tube, we are going to put the glucose. To the third test tube, we are going to put the fructose. To the fourth test tube, we are going to put here the sucrose. And to the fifth test tube, we're going to put the starch solution. Then, we're going to add to these 5 test tubes the fillings reagent. So this is the fillings reagent. So again, we're going to place these 5 test tubes into the water. So we will shake it first. Remember that this is water, this is glucose, this is fructose, this is sucrose, and the last one is the starch. Okay, starch, this is sucrose, this is fructose, this is glucose, and the water. Place water there. And we will heat that for 15 minutes. "15 minutes had passed, and then let us try to observe what happens to the carbohydrates when added with the Fannings reagent and being heated. This is that of glucose. Observe what happens. This is the water with the Fannings reagent, then heated. This is the fructose, which is added with the Fannings reagent, then heated. This is the sucrose, which is added with the Fannings reagent, then heated. And this is the starch, added with Fannings reagent, then heated. Okay. Further heating, let us try to observe what happens to the color. Starting from the right, we have the glucose, followed by the fructose, then the sucrose, and lastly, the starch. The next reaction that we're going to exhibit for the carbohydrates is the fermentation test. Now, we're going to fill these 4 test tubes with the carbohydrates, which are glucose, then to the second test tube, we will fill this with galactose. Then to the third test tube, we're going to fill it with sucrose. Then to the last test tube, we're going to fill it with starch. Then to each tube, we are going to add this with equal volume of the baker's yeast. So this is our baker's yeast. since we put 5 ml of the carbohydrate solution into each test tube. So we are going to add also 5 ml of the baker's yeast to each tube. And we will set this aside for about 30 minutes and we will observe it later. So 30 minutes had passed and we are going to observe what happens to the carbohydrates added with the baker's yeast in order to ferment. So for glucose, try to see. Then this is that of the galactose. This is the sucrose. And this is the starch. So what can you say about the fermentation reaction of the different carbohydrates or the different sugars, including the starch, with the baker's yeast? The last reaction that we're going to demonstrate is that of the iodine test. So in the iodine test, we're going to use here the starch solution. Let's use 5 ml of this starch solution. To this starch solution, we are going to add few drops of the iodine solution. Observe what happens to the color. Then I'm going to warm this in the water bath. After heating the iodine solution treated with the starch, let us try to see what happens to the color. After 15 minutes of heating the iodine solution with the starch, observe what happens to the color. A while ago, this was dark blue. And this time, what have you observed? Then I want you to observe the color when I'm going to run down this with water. Meaning, I'm going to cool this with the running water. So those are all the reactions exhibited by the carbohydrates towards the different reagents. What I would like you to do is You're going to write all the observations and answer all the questions given in the lab guide, and also write a formal report of the experiment. That would be all for today. This is your teacher, Professor Nesitas Ruiz of Holy Name University.